This section of 1.3 is going to deal with distance formula. Distance formula is used to find the distance between 2 points, or 2 ordered pairs, on the coordinate plane. Or, to put it another way, it's used to find the length of a segment on the coordinate plane. Because really, a segment is just a distance between 2 endpoints. So, whether you're looking at it as a distance between 2 points, or the length of a segment that has 2 points on the ends, it's the same thing. For instance, here are 2 points on the coordinate plane. If we want to find the distance as the crow flies directly between them, we can draw in that segment. There we go. It's a little tricky right now because that's not a vertical or a horizontal segment. It's got an angle to it. So what I'm going to do is I'm going to draw in the vertical component, which, let's see, that's 4 units tall. It's easy to tell if it's vertical or horizontal. So I'll draw in the horizontal unit. Start where I left off and finish at the other endpoint, and that is 3 units wide. And what we've formed then is a right triangle. The side of the right triangle that we don't know is, in this case, the hypotenuse. So that means we can use our old pal Pythagorean theorem, Pythagoras' theorem. Pythagorean theorem says a leg squared plus another leg squared gives you the hypotenuse squared. So they call the legs A and B. It doesn't matter which is which because you're just adding them up anyway. So A squared plus B squared on a right triangle is C squared, which is the hypotenuse squared. We already know A and B. We know one of them's 3 and one of them's 4, so I'll just pencil those in here. And that'll give you C squared. So we really got 9 plus 16 is C squared. 9 plus 16 is 25. Now to get rid of the second power, you have to take the square root. So I'm going to really call it square root 25, which is technically -5 and +5. In this case, I'm not going to worry about the negative because you really can't have a negative distance. So we'll just say it's 5. The length of our hypotenuse is 5. So as far as the definition is concerned, we see our old pal subscript 2 and subscript 1 make an appearance again. X subscript 2 means the second x value, or the x value from the second ordered pair. X sub 1 means the x value from the first ordered pair. When you subtract x sub 2 and x sub 1, you're finding the differences in the x values. That's the horizontal leg length in your right triangle. They call that delta x sometimes in science. Delta is a Greek letter. It means change. If you subtract the y values, you are finding the change in y. They call that delta y. So sometimes you'll see it written that way. But to get a delta value, you're just subtracting 2 things. And if you kind of look at what Pythagorean theorem said, if you isolate that Pythagorean theorem for C, you'd have to take the square root of both sides, and you get a square root of 2 things added up. And that's really what distance formula is. The C is isolated just like the D of the distance formula is. You have a square root on each side, whether it's Pythagorean theorem or distance formula. You're adding in both cases. And specifically, you're adding up something squared. Delta x squared in distance formula is like a squared in Pythagorean theorem. Delta y squared in distance formula is like b squared. So as an example, we want to find the length of this segment that has the given endpoints. I'm going to point out here that the negative 1, the first x value in the first ordered pair, is going to be called x sub 1. The number with it is y sub 1. In the second ordered pair, the first coordinate's going to be x sub 2, and the second coordinate's going to be y sub 2, and we can just plug these numbers, substitute these numbers into the formula. So x sub 2 is 2. And you're going to end up subtracting negatives here a lot. So here I'm subtracting because that's what the formula says. I'm subtracting a negative 1 because x sub 1 is negative. Look out for those double negatives. They hide on you. Don't let them startle you. All right. Y sub 2 is 4 minus y sub 1 is 1. And once you have the correct numbers written in, the math is pretty easy. 2 minus negative 1 is like 2 plus 1, so we'll call that 3. 4 minus 1 is also 3. If you add this up, whoops, terribly unprofessional. Three squared and 3 squared is like 9 and 9. 9 and 9 is 18. 18 isn't a perfect square, but it has a perfect square that goes into it, so I'm going to break it down into square root 9, square root 2, and square root 9 is just plain old 3. So 3 square roots of 2 is a simplified exact answer. If you need a decimal approximation, this is an irrational number. So if you need a decimal approximation, it pays to use a calculator. You get something in the ballpark of 4.2. That's if you're going to the nearest tenth. So what I'm going to do is I'm going to say this is approximately equals to, I'll use a wavy equal sign, which means it's been rounded off, approximately equal to 4.2. So my definite answer is 3 square roots of 2. My approximation is 4.2. And that is the distance formula and how it can be used.